We have another example on the board. This example, I would start from solving the value of Z total impedance, okay? So I have to remember that the formula for power factor says power factor is equal R over Z. Okay, this is my Z total. I have given power factor, I have given resistance, I can find Z total. Use algebra and write that Z total is equal resistance over power factor, where resistance is equal 500 ohms and power factor is equal 0.95. Perform the division, you're supposed to get the value of 526.31 ohms. This is the impedance. But if we want to find the full impedance, we're supposed to find the angle. Please notice that the power factor is given, and we have another formula for power factor, which says power factor equals cosine of angle theta. If you want to find angle theta, you're supposed to simply write theta is equal inverse cosine of power factor. So I have inverse cosine of 0.95. This is equal negative 18.19 degrees. Someone is going to say, how come? Because on my calculator I have 18.19. This negative came to the answer because I'm dealing with RC circuit. Okay, RC circuit is going to have always negative angle next to the impedance. So I can write that my total impedance is equal, this is the magnitude, 526.31 ohms and angle of negative 18.19 degrees. Okay, so this is the total impedance. Next, I'm supposed to find X of C. This is the series circuit, so the formula for the total impedance says Z total is equal R plus X of C. If you want to find X of C, you're supposed to move R to the left side and you are going to obtain the formula X of C is equal Z total minus R, where Z total we found is equal 526.31 ohms and angle of negative 18.19 degrees minus the resistance, and resistance is equal to 500 ohms. Use the calculator and you're supposed to obtain the value of 164.29 ohms and angle of negative 90 degrees. This is the capacitive reactance, this is my X of C, or impedance of the capacitor. Next, we're supposed to find I total. In order to find I total, I'm going to use Ohm's law. I total is equal voltage source over Z total. This is equal voltage source equals 100 volts over Z total, which is equal 526.31 ohms and angle of negative 18.19 degrees. This is equal 190 milliamps and angle of 18.19 degrees. This is the value of my total current. Please notice that we are talking about the series circuit. So it means that I total is equal to IR and is also equal to IC. So I can say that I found Z total, X of C, I total, IC and IR. Next, I'm supposed to find voltage across the resistor and voltage across the capacitor. I'm going to use Ohm's law to find these two values. So I have VR is equal IR times resistance, where IR we found is equal 190 milliamps and angle of 18.19 degrees times the resistance, which is equal 500 ohms. This is equal 95 volts and angle of 18.19 degrees. This is the voltage across the resistor. If you want to find voltage across the capacitor, simply multiply IC times X of C, where IC is 190 milliamps and angle of 18.19 degrees times X of C, and we found X of C is equal 164.29 ohms and angle of negative 90 degrees. This is equal 31.21 volts and angle of negative 71.81 degrees. This is the voltage across the capacitor. Next, we're supposed to verify if our answers are correct. You don't have to, but it's always good to do so, okay? So I'm going to write voltage source is equal voltage across the resistor plus voltage across the capacitor. Okay, this is KVL. So VR is equal 95 volts and angle of 18.19 degrees plus 31.21 volts and angle of negative 71.81 degrees. Use the calculator. Supposed to get the value 100 volts and angle of 0.003 degrees. Okay, so this is nothing else, just 100 volts and angle of 0 degrees. So please notice that we add voltage across the resistor and voltage drop across the capacitor, and we obtain the voltage source. So it means that our calculations so far are correct. Next, we're supposed to find the capacitance of the capacitor. I'm going to use the formula for the capacitive reactance. So if X of C equals 1 over 2 pi Fc. Supposed to use the algebra and solve this formula for C. So C is equal 1 divided by, open parenthesis, 2 pi times F times X of C. This is equal 1 divided by, open parenthesis, and I have 2 pi times 2500 over pi hertz times X of C, 164.29 ohms. Again, you're supposed to use the calculator. Don't forget about the parentheses. And you're supposed to get the value of C equals 1.22 microfarads. This is the capacitance of my capacitor. Next, I'm supposed to find the true power, P. Okay, so P is equal IR squared times resistance. Remember, write the formula first. Now, voltage source is equal 100 volts. If the voltage is not specified that this is peak or peak to peak, I assume that this is RMS. So that's why I'm going to also, if I use that voltage to calculate the current, so my current is also RMS, that's why I'm going to use this formula. And I have IR, which is equal 190 milliamps. Okay, I'm not going to use angle this time. Square times resistance, which is equal 500 ohms. And this is equal 18.05 watts. This is the true power in my circuit. Next, I'm supposed to find QC. QC is equal IC squared times X of C. So again, I have 190 milliamps to the second power times X of C, which is equal 164.29 ohms. This is equal 5.93 VAR, volt ampere reactance. Next, we're supposed to find apparent power, S. This is I total squared times Z total. Again, let me remind you, you're supposed to always write formula first, okay? So we have 190 milliamps to the second power times Z total, which is equal 526.31 ohms. This is equal 19 volt amp. Okay, I found all my powers. So next, I'm supposed to draw the power triangle. So I have true power. This is my P equals 18.05 watts. And I have QC. So my QC equals 5.93 volt ampere reactance. And I have my apparent power. Okay, S equals 19 volt amp. And this is my angle theta. So basically we found everything, so the problem is solved.